Our second lecture video on the properties of gases will cover Boyle's law. Boyle's law relates the volume and pressure of a gas. Boyle's law states that if the temperature of a gas is constant, the volume is inversely proportional to the absolute temperature. As a proportion, it looks like V over V prime equals P prime over P, where V is the original volume, V prime is the final volume, P is the original pressure, and P prime is the final pressure. One important thing to watch out for with this equation is that the pressure must be the absolute pressure, not the gauge pressure. If you are given the gauge pressure, you have to find the absolute pressure. Remember, to find the absolute pressure, you take the gauge pressure and add atmospheric pressure, which is 101 kilopascal or kPa. If we didn't want to use proportions, we could say that V times P equals V prime times P prime. If two things, in this case, the volume and pressure, are inversely proportional, it means that as the volume increases, the pressure decreases, or if the volume decreases, the pressure increases. Basically, if one goes up, the other goes down. Let's take a look at Boyle's law. In the picture on the left, we see that we have a large volume, so the pressure goes down since there are fewer interactions or collisions between molecules. On the right side, the stopper in the beaker is pushed down, so the volume decreases. When the volume decreases, the pressure increases because there isn't as much space for the same number of molecules to move around, so they collide more often, increasing the pressure. To review Boyle's law, it states that as the volume increases, the pressure decreases, and as the volume decreases, the pressure increases. Let's go through a calculation of Boyle's law. Some helium occupies 12.0 cubic meters at a gauge pressure of 237 kPa. Find the absolute pressure when its volume is 27.0 cubic meters. First, we will write down everything we know. The original volume, V, is 12.0 cubic meters. The new volume, V prime, is 27.0 cubic meters. The original pressure, P, is 237 kPa. However, we need the absolute pressure, not gauge pressure, so we will take the gauge pressure and add 101 kilopascals. This gives us an original absolute pressure of 338 kPa. We are trying to find the new pressure, P prime. The basic equation we will use is Boyle's law, which says that V prime times P prime equals V times P. We can rearrange to get our working equation, which is P prime equals V times P divided by V prime. Substituting, we see that P prime equals 12.0 cubic meters times 338 kPa divided by 27.0 cubic meters. This means that P prime is equal to 150 kPa absolute. There is also a way to relate the density and pressure of a gas assuming constant volume. The density of a gas is directly proportional to its absolute pressure as long as there is no change in state, meaning the gas doesn't condense into a liquid or freeze into a solid. As long as this is true, we can say that D divided by D prime is equal to P divided by P prime, where D is the original density, D prime is the final density, P is the original absolute pressure, and P prime is the final absolute pressure. We could also say that D times P prime equals D prime times P, since they are directly proportional. As a reminder, directly proportional means that as one quantity increases, the other quantity increases as well, or if one quantity decreases, the other quantity also decreases. Let's take a look at a density and pressure example. A gas has a density of 3.09 kilograms per cubic meter at a gauge pressure of 176 kPa. What is the density at a gauge pressure of 310 kPa? First, we will write down everything we know. The original density D is 3.09 kilograms per cubic meter. The original pressure P is 176 kPa. However, since this is a gauge pressure, we have to convert this to the absolute pressure. To do that, we will add 101 kPa, and this gives us an absolute original pressure of 277 kPa. The new pressure, P prime, is 310 kPa. However, this is also a gauge pressure, so we have to again add 101 kPa to get the absolute pressure of 411 kPa, and we are trying to find the new density, D prime. The basic equation we need to use is that d prime times p equals d times p prime. We can rearrange this to solve for d prime, which equals d times p prime divided by p. Substituting, we have 3.09 kilograms per cubic meter times 411 kPa divided by 277 kPa. This gives us a new density, d prime, of 4.58 kilograms per cubic meter. This concludes our discussion on Boyles' law, density, and pressure.